Welcome pre-cal students to class today on this Wednesday the 26th. Hope you guys are doing well and hope you're ready to learn some math today. Let's quickly go over some announcements that you need to be aware of. First of all, there will be a quiz on Saturday. Please remember that all quizzes are due by Tuesday, okay? So keep that in mind. Mind your tests are due today, Wednesday. All questions completely asked and the entire test finished. So please make sure you get your test turned in today, Wednesday, and then stay on top of your integrity sheets. They're called integrity sheets because you need to be honest and do your homework every day, okay? Please stay on top of these and don't get behind. It's really difficult when you get behind to make up the math. Let's take a quick second, and I do mean a quick second, and review what we learned yesterday. It will be quick, so please don't fast forward this part of the video, okay? I'll be really brief. Remember, we learned how to look at a function and write it in standard form. So your x cubed would come first, then your 2x squared, then your 11x, and then your 12. Highest exponent first, working your way down. Lead coefficient would be 1. The degree would be a third, and because it's a third degree, we call that a cubic function. So we learned yesterday how to do those three things. We also learned how to look at the fact that if the graph is if the function has an even degree and a positive lead coefficient, the end behavior is up and up. If it's even and negative, the end behavior is down and down. And if it's odd right here, odd degree, positive lead coefficient, it's down and up. And if it's an odd degree and a negative lead coefficient, it's up to the left and down to the right. And then we also learned how to test numbers. Everywhere there's an x, you would put a 2 in right here and see if you get out a 0. And then also we'd put in a -5 everywhere there's an x, a -5, and see if you get out a 0, okay? And if you do get out a 0, then that number is one of your zeros, and if you don't, then it's not. So that's a quick review. I'm not trying to teach this. You should know this already from yesterday. Let me get a drink here. But I just wanted to quickly refresh your memory as to what we looked at yesterday. Now, today we'll be taking our study of zeros of polynomial functions a little further, okay? And we're going to learn about something called multiplicity. It's pretty easy, but we have to know this. It's very helpful. We're also going to learn a little bit. We're going to learn some about the graphs of polynomial functions by studying their number of terms. And also, I should have put this, their number of zeros. Okay, I should have typed that also. All right, so keep all of this in mind. And doesn't that sound exciting? I'm sure you're on the edge of your seat with excitement. And of course, let's go ahead and get started. Okay, here we go. Your heading today is Multiplicity of Polynomials, lesson 3.1. And the date today is the 26th, if you'd like to keep track of that. The 26th, okay? Multiplicity of Polynomials, lesson 3.1, and the date today is the 26th. Now, there's no need to take notes on this. Just kind of sit back and listen and watch. Let's pretend that you have a polynomial function like this right here. And pretend that I asked you to find the zeros for this function, okay? Well, no big deal. We know that f of x is really y, so I would have y equals x minus 2. And again, don't take notes on this, just watch. X plus 1, x minus 3. Now, if I ask you to find the zeros for this function, you should know what to do. When I ask you to find the zeros, I'm really asking you to find the what? X-intercepts. And if you're finding the x-intercepts, then everywhere there's a y, you're going to put a 0. So if I put a 0 right here, then obviously the right side is already factored for you. This is really easy. I mean, set this group equal to 0, you would get 2. Set this group equal to 0, you would get a -1. And set this group equal to 0, and you would get a +3. So there's your 3 zeros. Now, I just kind of wanted to show you what to do when the polynomial is already factored for you. Now let's take this a step further. Please take notes on this information. Let's use this polynomial function, and I want to talk about multiplicity. So please take notes and be careful. If I ask you to find the zeros of this function here, you know right away to put a 0 in for y, correct? Now watch this. If you put a 0 in for y, and now you found the zeros of this function, you know if you set this group equal to 0, you would get a -1. This group, you would get a +3. This group, a -1. This group, a +3. This group, a +3. And this group, a -5. Now, listen. You should know by now that sometimes when you factor a polynomial, you get repeated parentheses like x minus 3, x minus 3, x minus 3, or x plus 1, x plus 1. And so you really don't have to, when I ask you to list out the zeros, you wouldn't list -1 out twice, and you wouldn't list 3 out 3 times. I know that, okay? If I asked you to list out the zeros, you would say -1, 3, and -5. But multiplicity is so easy, but it's still important that you know this. When I ask you to list out the zeros and include the multiplicity, here's what you would write. See this -1? See how we had two groups that gave us out a -1? Do you see that? Well, you would write 0 at -1 with multiplicity of what? How many groups were there that gave you out a -1? 2. That's it. And you can use ditto marks if you want, like this. A 0 at 3 with multiplicity of 3, right? Because there were 3 groups. If you'll look, guys, there were 3 groups. There were 3 groups that gave us out +3. 1, 2, 3. So one of your zeros is at 3 with a multiplicity of 3. And then of course your last zero you have a 0 at -5 with a multiplicity of, well, obviously just 1, because there's only one group that gave you out a -5. Now sorry guys, drinking a little coffee here. Now that should really be easy, is it not? I mean, if you can factor everything and break it down, then the multiplicity is easy. And a little warning here, guys. If you have 0 equals something like x minus 2 squared, like that, that does mean you write the parentheses again, like that, and then you would have a multiplicity of 2, okay, for the 0, 2, okay? But anyways, so multiplicity is really easy, and probably in your minds right now you're saying, this is really dumb. Why would I want to do this? Well, let me answer that question for you. Let me show you why multiplicity is important and also helpful, okay? Go ahead and copy this function down, and I want to show you on this, excuse me, you already have this copy down. Sorry guys, you already have this copy down right here, but let me show you why this multiplicity is so helpful, okay? And I wish, let me go back a page here real quick. Just give me a second. Good, I did not delete this. Okay, let me go ahead and just pull this over to the next page. There we go. Okay, now let me show you why multiplicity is so important. Please take some really good notes on this, okay? Look, we know our zeros are -1, 3, and -5, right? So I'm going to go ahead and put those on the x-axis, because remember, a 0 is an x-intercept. Okay, there we go. Now listen to me, students. Matthew, Caleb, watch this. Whenever you have an x-intercept, yes, sometimes the graph will come down. We know the graph is going to hit that point. It'll hit the point and maybe come down and curve and go back up. But sometimes a graph will do this. See if this makes sense. Sometimes a graph will come down and hit a point. Now watch this. And then instead of going through the x-axis, it'll go back up. And then maybe come over here and come down like this. Wouldn't it be really, really, really cool if you could look at your zeros without doing any work and know whether the graph's going to hit the point and go back up, or in some cases, if the graph's below the x-axis, it'll hit the point and go back down like that, right? Wouldn't it be cool if we could just know that? Well, there is a way to do it using multiplicity. And by the way, you need to know this word. Whenever a graph hits this x-intercept and goes back down, or hits an x-intercept up top and goes back up like this, it's called tangent. Okay? So you would say the graph is tangent to -5, tangent to the x-axis at -5, or tangent to the x-axis at -1, or tangent to the x-axis at 3. Okay, so get used to that word because the book's going to use that word in your homework. Okay, so here's what we do. This is so easy. Take some really good notes on this, guys. Okay, 1, 2, 3, 4, 5, -1 and 3. Whenever your multiplicity, now write this down, whenever your multiplicity is even, then that means you have a tangent situation. And whenever your multiplicity is odd, there is no tangency. Let me get a drink here real quick. So if you were to graph this polynomial function right here, things just got really, really easy for you, or easier than they were. You know that your -1, look right here, has a multiplicity of 2. And 2 is even. So you know the graph is going to hit right here. If it's up here, it's going to hit and go back up. Or if the graph's down here, it's going to hit and go back down. That's a really big help. Here, you know there's no tangency, so the graph's either going to come down like this, or it's going to come down like this and cross to the x-axis. And same thing over here. So that's why multiplicity is so important. It tells you when your zeros are points of tangency, and it tells you when they're not. I hope that makes sense. If not, back the video up and listen to it again, okay? When multiplicity of a zero is even, then at that zero, the graph is tangent to the x-axis. And if the multiplicity is odd, like it was here for 3 and here for -5, then you know there's no tangency at these two zeros, okay? The graph will hit that point and continue going down, or hit that point and continue going up, okay? All right, that's why multiplicity is so important. So with that in mind, let's do one example. I want you to find the zeros and the multiplicity for the polynomial and then interpret what this means. So let's do this together, okay? Or you can work ahead if you want to. If I asked you to find the zeros, I'm going to move this over a little bit. If I asked you to find the zeros of this function, you would put 0 in for f of x right here, and you would factor this. So we have 4 terms. We know what to do. We pull out what's common in the first two. So we pull out an x squared, and we're left with x minus 3. We come to these two terms right here, and we're left with, there's a negative sign here, so pull a negative sign out. We're going to pull a 9 out. And I'm going to put x minus 3 because that's what I put over here. Let's see if that works. -9 times x, -9 times -3, we're totally good. And now you write your matching parentheses once, and then your leftover two terms right here. And then obviously you can factor that second parentheses again. And there we go. So we took the polynomial function, set it equal to 0, factored, and now we know our zeros are going to be +3, -3, +3. Okay, so do you see what we have? Let's come over here. Let's interpret what we did using multiplicity, okay? We know for this number, for this 0 right here, and for this 0 right here, I know I have a multiplicity of 2. And then -3 only has one group that gave me out a -3, so I have a multiplicity of 1. All right, now I asked you to find the zeros and the multiplicity, and you did that. Now interpret what this means. Okay, here's one zero at -3. Here's the other zero at +3. Now, the one that has an even multiplicity, which is my 3, I'm going to simply say, I'm going to put the word tangent and draw an arrow. And that's all you need to do when I ask you to interpret. That's it. You're just simply saying, hey, at this point right here, the graph will be tangent to the x-axis. And over here, of course, we have no tangency, okay? So I guess you could put not tangent if you wanted to, and then draw an arrow, okay? So multiplicity is very helpful. It tells you when a graph is tangent or not tangent to one of your zeros, okay? Let's continue on. Okay, let's finish up the lesson today studying the maximum number of zeros and terns that a polynomial can have. This is very interesting. Let's use the function that we looked at just a couple of minutes ago, this one right here, okay? There are two things that you need to write down, that you need to know. One is about the terms of a polynomial graph, and the other is about the zeros of a polynomial function. Okay, and here are the two things that you need to know. Number one, the maximum number of turns that a polynomial graph can take is always one less than the degree of the function. Now, look at this function, look at this graph up here, please. Well, we'll talk about that in just a second. Let me go ahead and put the second thing up here. Number two, the maximum number of degrees, the maximum number of zeros that a polynomial function can have is equal to the degree of the function. Now, there's a key word here you need to see, okay? Maximum and maximum. In other words, I'm not saying that the graph has to have a certain number of turns. I'm saying it will have at the most so many turns. And I'm not saying the graph will have a certain number of zeros, or the function. I'm saying it will have a maximum number of zeros, okay? Now, let's see. If I asked you to consider this function, and if I asked you, what's the maximum number of turns this polynomial graph will take? Well, it's always one less than the degree. So the degree of this function is a 3. Go one less than 3, and you get a 2. So you know this graph, and by the way, here's something else you know. Think about this for a second. You also know that the degree is odd, and you know the lead coefficient is positive, so you know it's going to be going down over here and up over here. So at the most, this graph could never do something like this. You know that for sure. How do you know that, Mr. Earhart? Well, watch. The graph went up, it took a turn here, that's 1, took a turn back up, that's 2, took a turn back down, that's 3, and then turn back up, that's 4 turns. And I just told you the maximum number of turns that the graph could take is 2. This is very helpful, guys, okay? Now, so the maximum number of turns this graph could take would be 2 turns, something like that. There's 1 turn and there's 2 turns. How do you know when a turn takes place? When it changes directions. So you're going up, it hits here and goes back down. Hits here and goes back up. That's 2 turns. Now, am I telling you, please listen to me, am I telling you that the graph has to take 2 turns? Not at all. Not a bit. I mean, it might take just 1, okay? I'm not sure if that's possible in this case because it has to go down and then go back up again. But my point is it does not have to take always that exact number of turns, okay? Sometimes it can be 1 less than that, okay? Or excuse me, yeah, it could be less than this. It doesn't be that number exactly, okay? So, but what it does is it tells you the maximum number of turns the graph will take. Also, if you'll look at this, if I ask you to tell me the maximum number of zeros a polynomial function can have, it's always equal to the degree. Always, okay? So at most, you'll have 3 zeros for this function. Now, listen, guys, I'm not saying you will have 3. You might have 2 zeros. You might have 1. Okay? But at the most, this function will have 3 zeros. Okay? 3. That means, in other words, at the most, this graph will have 3 what? X-intercepts. Remember, zeros and x-intercepts are the exact same thing. Okay? So, these are 2 helpful items that we need to know, because we are going to start graphing these pretty soon. And I'm going to let you use your graphing calculators a little bit, but you're going to have to prove to me that you know how to do this without a graphing calculator also, okay? Let me get a drink here. Okay, now let's do something that's really cool and really helpful, and then we're finally done with the whole video. Let's sum up all of the tips that we have learned about polynomial graphs in the past couple of days. Are you ready? Here we go. Take some good notes. I want you to consider this polynomial function. Please write this down. You'll have to pause the video a lot. I'm going to go fast here, okay? Consider this polynomial function. First of all, I want you to find the zeros. Okay, no problem. Let's find the zeros for this function. We already have part of it factored. We put a 0 here, and we already have 1 parentheses, x negative 5. And then over here in the other parentheses, I'm going to pull out what's common in the first 2 terms, x squared, and you're left with x plus 3. And then out of these 2 terms, I'm going to pull out a negative 25. And that should also leave me with an x plus 3. Alright, so now write down the matching parentheses once, and you're left over with x squared minus 25. And of course that can be factored again. And I won't go over that factoring. You should know how to do that. So there, we're almost done. We're finding the zeros. So we're just basically reviewing a lot of stuff that we've done for the past many days, okay? So there are the zeros, okay? Or excuse me, there's the factored form. So I know my zeros then are going to be a negative 5, a positive 3, or a negative 3, a negative 5, and a positive 5. So there, I found my zeros, okay? I think it would be very helpful if I could do this and do this. And I kind of messed that up a little bit. That's all right. And let's slide this up here. Let's not do that. Alright, very good. Okay, so we found our zeros. That's pretty easy. And by the way, notice, I think I made a mistake on 1. Well, maybe not. Let's see. Let me go back real quick here. Yeah, this should be a positive 3 here, right here. Alright, let's fix that real quick. Or a negative 3. This should be a 3. Okay, there we go. So I found my zeros. We're just reviewing a lot of stuff we've done in the past, okay? All right, let's continue on. Let me, and I'm really sorry, guys. I'm going so slow here. I apologize. I know what I'm doing. I just want to keep this stuff together. Okay, now let's continue on. So we found the zeros, okay? Now, let's talk about multiplicity. We know we have even multiplicity, right? We know that right here. And so make note of here off to the side. Notice we have negative 5 and negative 5 2 times. That's an even multiplicity. So we know that negative 5 has a multiplicity of 2. So we know at negative 5 here on the graph, we know at negative 5 the graph is going to be tangent to the x-axis. Okay? So I'm going to put off to the side right here. Tangent at negative 5. Is that okay, guys? That should make sense. Okay. All right, let's continue on. So I know I have a tangency at negative 5. So tangent C at -5. Okay, decide what the end behavior is. Okay, this is a great review. All right. Now be very careful on this here. Notice this is not written in standard form. Okay. Now I'm not going to take a lot of time and do this for you, but you need to trust me on something. Okay. Trust me that if you were to take this x right here and multiply it through, let me back up. You cannot tell me what the end behavior is. Do you know why? Because you have to know the what? Remember, you have to know the degree, and you have to know what else? Lead coefficient. And you do not know the degree, and you do not know the lead coefficient until your polynomial is written in what form? Remember all this? Standard form. So I'm not going to waste a lot of time and make you write it in standard form on your own. Just trust me. The way to write this in standard form is to take your x, multiply it through. That would take a lot of time. Then take your -5 and multiply it through. Okay? So just trust me. If you were to write it in standard form, your lead term would be this. Just trust me. Make a note of this somewhere. That would be your lead term. Okay? So if that's your lead term, okay, then that means this is your degree. So we have a fourth degree. All right? And our lead coefficient is a +1. Okay? So think about that. I know that I have an even degree. A lead coefficient is positive. So I know the graph is going to go up and up. Okay? So I'm just going through all these things that I've learned, and on a test or a quiz I could ask you any of these questions and you should be able to do this. Okay? Alright, let's continue on. I know I have to keep copying this stuff. I wish I would have thought of that, but I did not. So I have to write this again. Tangent C at -5. The lead term is this, so I know it's going up and up. Now decide how many maximum turns it will take, how many maximum zeros it will have. Okay, remember I told you already, this is your lead term. I'm not going to make you go through and do all that multiplication. This is your lead term. Okay, so your degree is 4. So the maximum number of turns it will take is 3. Remember, it's always 1 less than the degree. If the degree is 4, then you know the maximum number of turns the graph will take is 3. And what's the maximum number of zeros you will have? Well, that's always equal to the degree, 4. Now, in this case, I only have 3. Mr. Earhart, you have 4. No, -5 and -5 are the same. If you were to come down here and plot your zeros, you would have 1 at -5, you would have 1 at -3, and then 1 at +5 way over here. Okay, so this polynomial graph only has 3 zeros, but it still fits. Okay, we can look here and say, okay, how many maximum zeros was I allowed to have? Well, I was only allowed to have 4 maximum zeros. Okay, and so I'm fine. I only had 3 zeros, so I'm totally fine. Okay, so how many maximum zeros could I have? All right, and then lastly, I think it's the last one. Yeah, find the y-intercept. So let's put all this down real quick. Okay, let's wrap this thing up. There are your zeros: 1, 2, 3, 4, 5, and -3, and +5. Okay. We have even multiplicity at -5, so I'm going to circle that point for now. We know it's going to be tangent to that point, and that's not -5. This is -5, so we know the graph is tangent right there. End behavior, we said it's going to go up, and it's going to go up. Decide how many maximum turns it will take. 3, because the degree is 4. Your lead term was 1x to the 4th. And maximum number of zeros is 4, and we're okay there. We have 3. Now find the y-intercept. Okay, look, I want to show you something that's really, really, really easy to do. Finding the y-intercept. Okay, guys, how do you find the x-intercept? You put 0 in for y. Well, how do you think you find the y-intercept? You put 0 in for x. Do you not see how quick we could do that? If I put a 0 in for x, I get 0 minus 5. If I put a 0 in for x here, I get a 0. If I put a 0 in for x, 0 squared times 3 is 0. If I put a 0 in for x, 25 times 0 is 0. And then -75. So 0 minus 5 is negative 5, and 0 plus 0 minus 75 is negative 75. All that I have to do is multiply those two together, and I get 375. Now I know you're not going to go way up here on the y-axis to negative 375 and put a point, but you know what that tells you? That tells you the graph is shooting way up high over here. Okay? All right, so everywhere there's an x, you put a 0, and you can find the y-intercept. They're going to ask you to do that in your homework. I've never taught you how to do that because it's so easy. In fact, you know how to do it. I've taught you in the past, whenever you're looking for the y-intercept, put 0 in for x. And anyone can put 0 in for x right here. That's easy to do. So let's see what we know. We know the graph is going to come down, and we know it's going to hit here. And we know that's a tangent point, so we know it's going to go back up. Now, I'm not sure how far it's going to go back up, but we know it has to come back down and hit here. Okay? Now, let's see here real quick. Okay guys, I'm back. Notice I paused the video. And one of the things about making videos that's pretty frustrating is please understand that your teacher's not perfect. And so if I was in class teaching you and I would make this mistake, it's got to be frustrating for you guys, because if you caught this mistake that I made about 4 pages earlier, you're sitting there thinking, oh boy, he's going to find this out later. And I'm sorry guys, it's just, you know, if you were there in class, you would raise your hand and you would say, oh, Mr. Hart, you made a mistake right there, which happens to all teachers all the time. So I do apologize. But back here on the page where I factored, right here, do you see something? Your multiplicity would be at positive 5, not negative 5. You have a positive 5 for this, a negative 3 here, a positive 5 here, and a negative 5 here. So you have 2 positive 5s. We'll make this a positive 5. We have 2 positive 5s and 1 negative 5. So if you'll look in your notes and go way back to your factoring, you should see this somewhere. And if you see that, then you realize there's a positive 5 here for this parentheses and a positive 5 here for this parentheses when you set them equal to 0. And I had 2 negative 5s, and I'm really sorry about that. I wish I could change that, but I can't. So we're going to kind of start this over here. Your multiplicity is going to be at positive 5 over here. And so here's what I know. I know the graph's going to be going up over here like this. And it's going to hit here and be tangent here, okay, and then go back up. And then you know what you know? You know that your y-intercept is at 375. So guys, you know this thing's going to shoot way, well, it's not very straight line there, but this thing's going to shoot way up here so high. And it's going to hit right around, we'll put a point here, and we'll label that point 375 on the y-axis. Then we know it's going to come back down. Now, we know for a fact it's not going to hit here and curve back up, because that would mean it's tangent right there, and we know the graph's not tangent there. We know it has to go through the x-axis, and I'm not sure how far down it would go, but then it's going to curl back up, and then it's going to hit here. And notice my little line here, it's going to continue going up, and it's not going to come down again. Kind of cross that off, okay? So there we go. We sketched the graph just by knowing these 5 things. And I feel really bad about that mistake I made earlier, but you get the point. These points of tangency are a big help. And knowing the maximum number of turns is a big help. It took 1 turn, then it came back down, that's 2, then came back up, that's 3. End behavior is a huge help. So these are the things we've learned now for the past couple of days, okay? All right, here's your homework. It is rather long. I'm not going to lie to you, but if you will trust me, the problems are pretty quick. They're asking you questions like true and false. Is the point here a point of tangency or is it not? The problems are already factored for you for the most part. Almost every single one of these are factored for you. All of these are factored for you already. And then these here, these 12, they're just asking you to look at the number of turns and the number of zeros and kind of match up equations with graphs and stuff like that. So even though it's 25 problems, it will not be that long of an assignment, okay? So please get to work on your homework. Call or email if you have any questions. I hope you guys have a good day today.